Hi, and welcome to our first Level 3 integration video. In our integration videos, we start the process of reversing the process of differentiation and all the applications that it leads to. We're going to start off with the integration of polynomials. We know differentiation is the process of taking a function and turning it into a gradient function. Now we're going to start the idea of reversing that process called anti-differentiation. But we're going to replace that with a different name called integration. Now, integration is actually a lot bigger than anti-differentiation, and hopefully as the next series of videos, this whole lot of videos goes on, you'll suddenly realize what integration starts to become. All right, let's go through our rules. If we have a number a times x to the power of n, we add 1 to the power of n, and we divide by the new power of n plus 1. And then don't forget to plus on this constant called c. Remember, when we differentiate, if we have a number by itself, it disappears. Now we're reversing the process. We're going to bring back a c, a number by itself, in case it was there in the first place. All right, for example, 3x to the power of 4. We add 1 to the power of 4, and we divide by the new power of 4 plus 1, and then we plus our constant c. That simplifies down to 3x to the power of 5, divide 5 plus c. All right, what if we just have x to the power of n by itself? Well, the same thing. We add 1 to the power of n, divide by the new power of n plus 1, and plus our constant c. For example, x to the power of 6 will integrate to x to the power of 6 plus 1, divide by the power of 6 plus 1, and plus our constant c, which simplifies to x to the power of 7, divide 7 plus c. What if we have a number by x, a times x? Well, remember, x is x to the power of 1, so a times x to the power of 1. So we add 1 to the power of 1 and divide by the new power of 1 plus 1 and plus our constant c. So 8x will integrate to 8x to the power of 1 plus 1 more, divide by the new power of 1 plus 1 plus our constant c. And this will simplify down to 8x squared divided by 2 plus c. And finally, if we have a number by itself, don't get confused with differentiation, we bring the x back and we plus our constant c. So for example, 7 will integrate to 7x plus c. Right, a couple of examples to show you how this works. This sign here is the integration sign, or just think for now, the anti-differentiation sign. And this means with respect to x. Well, there's only x's and numbers in the expression, so for now, don't get too hung up on it. We'll talk a lot more about what this means as we get into the applications. All right, so let's start with 4x squared. We're going to add 1 to the power of 2 and divide by the new power of 2 plus 1. The 7x, we're going to add 1 to the power of 1 and divide by the new power of 1 plus 1. The minus 9, we're going to bring the x back, and we're going to plus our constant c. And this will simplify down to 4x cubed over 3 plus 7x squared over 2 minus 9x plus c. Example 2, let's integrate 5x to the power of 4 plus x cubed minus 8x minus 2 with respect to x. So let's start with our 5x4, add 1 to the power of 4 and divide by the new power of 4 plus 1. The x cubed, we're going to add 1 to the power of 3 and divide by the power of 3 plus 1. The minus 8x, remember that's an x to the power of 1, so we add 1 to the power of 1 and divide by the new power of 1 plus 1. And the minus 2, we're going to bring back the x, and don't forget to add your constant c. Now this simplifies to 5x5 over 5 plus x4 over 4 minus 8x squared over 2 minus 2x plus c. But notice the 5's will cancel, and 8 divided by 2 is 4. So this simplifies even further to x to the power of 5 plus x to the 4 over 4 minus 4x squared minus 2x plus c. Great, thanks for watching.